So 1.2 is on square roots, and let's dive into some examples. Well, I already used square root of 25 in the last example or in the last section. So let's maybe start with something a little bit different. Let's make this a little bit thicker so you can see it properly. And let's do something like, oh, I don't know. Do you guys know this one? What is that approximately, or not approximately, but I guess precisely? Maisie? This is equal to 12. Everybody agree with that and okay with that? Okay, so you know those. Let's maybe just talk about some of them. So we would call 144 a perfect square because it's a number that we can take the square root of and get a whole number as our answer. So let's start by listing together the perfect squares, starting with what's the smallest perfect square we could have. You can just call them out. 1. What's the next one? 4, and then 9, 16, 25, 36, 49. Good. Yep. 100, and then good. Okay. Oh, you guys are good. Awesome. I'm impressed. I wasn't even expecting that much, so this is a great start. Okay, good. So those perfect squares, the reason why I want to mention them or go over them is when we're doing questions or examples, we want to look, like if you see any of those numbers, that should be sort of like a indication that we can simplify that or we can do something with that. So look for those perfect squares or those numbers in our calculations. And basically, again, I think I said it last week, but math is basically about finding shortcuts and making life easier. Except people get tangled up in the mess and they don't seem to feel that way by the time they walk out of it. But if we do it properly, that's the purpose of it. It's to find shortcuts or to find smarter ways of doing things to make our life easier. So that's what we're going to use this for as well. Okay, so let's determine the square root of these numbers. So I'm going to give you a few examples to work with that aren't quite so straightforward because those ones we just mentioned, it sounds like you all know those. What if we had something like this? So don't call out the answer, but see if you can think your way through this because there's a little bit more that I've added into this. And you may have never have done this before, but just see if you can, based on what you know about square roots, see if you can think your way through this. What might this be equal to as we're working our way through this? David? Almost. What's the square root of 81? Yeah, so it's going to be...
The square cancels out, yeah, so it's 81x.
Oh, look at this. We have controversy in the first example. I'm so glad this is happening. Let me show you this. And this is, I'm thinking you've never done this before, right? So technically, I could rewrite this to say the square root of 81 times the square root of x squared. So I could separate them. So what that means is because both of these things are under that root sign, I need to square root both of them. Does that make sense? So the square root of 81, so you just told me that was 9, and the square root of x squared you got in the first shot. So it actually would be 9x. That would be the answer. Let's sort of look at thinking about how we would get to 81x squared. What's the opposite of square rooting something? Squaring it. So let's square 9x, meaning let's do 9x times 9x. And what do we get when we're doing that? What would be 9 times 9? 81. And what's x times x? X squared. So that's how you could double check to see, like, did I do this right? And if you did this right, then you should be able to do the opposite operation to check to see if what you did was correct. So I'm thinking that's probably the first time you've seen this, when you have numbers and you have variables thrown into under a root sign. Is that true? First time? Yes and no. So it probably depends on the class and depending on how far you got last year. Okay, so let's try something like this. If I gave you this as a question, what would you write as your answer? And again, I'm not even sure if you've done that before. We talked a little bit about this. What is this? Pardon? This is an imaginary number. So when I get something like the square root of -9 as a question, basically we can't do it because it's an imaginary number. So how I would give my answer is I would say that this is undefined. Good? That also happens if we have a 0 in the denominator. Like, we're not doing that stuff right now, but just so you know, if we ever have a question where we have 0 at the bottom in the denominator, we could say that it's undefined. Okay, how about the square root of 0? What's the square? 0's a weird one, even weirder than 1. 1's a weird one because what's the square root of 1? It's just 1. So that's very unique because there's no other number that does that. The square root of 1 is 1. What's the square root of 0? Because sometimes 0 has its own set of rules. Well, 0 times 0, you just have nothing to work with. So this would still just be equal to 0, right? Good? I just thought it would be helpful if we go through some weird ones together. So how about something like this? Root 16 over 121. And again, I'm not even sure if you have ever done this before. And that's great because we could do it together. But without me even teaching you this, can you think your way through this? Maybe what we did with 81x squared might be helpful. Yeah. Mason, right? Sorry, Mason, what'd you say? 4 over 11. Does everybody agree? Yeah, so I just want to show you, yeah, so this really is 4 over 11. And again, I'm just going to show you down here the reason for that. Anytime you see a big, huge root sign, we can separate the things underneath it as long as it's multiplication or division going on underneath it. If it's addition or subtraction, we can't do that. But when we have something like this, we could say this is the same thing as root 16 over root 121, and we know that that's equal to 4 and that's equal to 11, which explains how we would come up with this. So far, so good? Questions about anything so far? Okay, so then maybe to really clarify what I just finished saying to you, what would you have if you did root 100 plus 25? What would we have if we had root 100 plus 25? It's a little bit sneaky or tricky. Yes.
10 plus 5.
Can we do 10 plus 5? I'm glad this is coming up again because it's so tempting to do that. We were allowed to do that back here. We could do root 16 over root 121. So this is we're not allowed to do that down here because of that plus sign in the middle. Even though it's not written there, you can think of it this way. It's kind of like there's a set of brackets there saying you have to do that part first and then you can go to the outside or the root part after. So therefore, how could I give an answer for this? Or what can I do with this? Or what's the only thing I can do with this? The square root of 125, so I do add them together, and is 125 a perfect square? No, so we only have a couple of options here. One of them would be to punch it into our calculator, but we don't want to do that. So you could leave it like this. This is what I would call exact value form. If I punch it into my calculator, I'm going to get a decimal with a whole bunch of digits, and that's approximate value form. Stuff you don't really need to know yet, but I figure I might as well teach you this in grade 9 since, I mean, I'll just mention it. I'm not expecting it from you, but maybe it's good for you to know that. Approximate value form is when we have decimals and we round it off. Exact value is when we leave it like this because it's precisely root 125. So far, so good? Okay, and then, I don't know, are you still okay with, I skipped the basic square roots and dove right into the hard and confusing stuff. Are we okay with that? Seems to me like you're okay with that. Good? So you ready and you're up for another hard one? 0.25, the square root of 0.2, oh, I'm having some troubles. Okay, so feel like you're all probably kind of thinking something, but I want to know for sure what this could be equal to. Landy? 0.5? Do we all think 0.5? What else are we thinking? I love when this happens and we have like 5 different answers. What else are we thinking? 0.05. David? Okay, 0.25. Oh, 0.5. 0.5 times 0.5. Okay. Controversy. I love this. Okay. How could we find out for sure without a calculator? Mason? Yeah, like we could, we're not going to actually do this, but we could do like 0.5 times 0.5, multiply that out and see what we get. Or we could do 0.05 times 0.05 because these seem to be the ones that people were debating between. Does that make sense? So we could work our way through our multiplication, move the decimal over 2 times for this one, etc., etc. But we're not going to do that. Let's find another method. I'm going to show you another new method to find a precise answer and figure out who's right and who's wrong here. Is there another way that I could rewrite 0.25? What is that the same thing as? Esty? Yeah, it's the same thing as 1/4. Oh, I didn't even think of that, but you're right. This is the same thing as 1/4. Everybody see that and agree? Or there's another one that I was thinking in my head that's like pretty similar to that. If I see 0.25, that's 25 over what? 100. How did I know to put 2 zeros there? Because I'd have to move this over 2 decimal places. Make sense? So maybe we can work through both of these because they both will give us the same end result. So Esty, thank you for that. That didn't even occur to me, but you're right. So according to what we just learned like not that long ago, how can I split this up? If I'm doing square root of 1/4, it's like saying square root of 1, which is 1 over square root of 4, which is 2. So it's a half, which is the same thing as 0.5. So there's our answer. So those of you who were fighting for that, you were right. And here we could do the same thing. What is the square root of 25? 5. What is the square root of 100? So do you see that we would get the same thing any which way that we do it? So take your pick of what you find the easiest or what makes the most sense to you because they actually mean exactly the same thing. It's just preference of. Do you see that 1/4 is just a reduced fraction of 25 over 100? So that's why it's the same thing. Good? Okay. Let's do another one. Let's say, for example, we have the square root of 0.0036, and I'm going to give you a minute to do that one on your own. What would be the answer in that case? So there's usually debate over how many zeros, where to put the decimal, and all of that stuff. So how can we find out for sure what the answer would be? So I'll give everyone just a minute, those people that are writing. Anybody want to call out the answer? Maisie? 0.06? Do we all agree? Mason? 0.006? I love when this happens. Okay, similar to the last one, do you see this is why we're learning strategies, because it's hard to look at it and to know for sure if it's 0.06 or 0.006. And they're so close. So let's go through the work to figure out which one is correct. What would this be as a fraction? 36 over what number? 1,000? Well, to figure this out, if I'm going to make this 36, I have to move this over 1, 2, 3, 4 times. So do you see I'd have to write 1 with 1, 2, 3, 4 zeros? So it's not 1,000. What number is that? That's 10,000. Do you see the process or the thought process to get that? And then we can take the square root of them separately, which we haven't really done before with like so many zeros. But what's the square root of 36? That one we all know. We know that we have 6 at the top. And at the bottom, if I have something with 4 zeros and I square root it, how many zeros should I end up with? You always end up with half the number of zeros. Did we know that trick or that rule? So we would get 100, right? And I will tell you this little rule or trick. If the answer is given to you as a decimal, then we want to give, if the question, is given as a decimal, we want to give the answer as a decimal as well. So I want to know, what is 6 over 100 the same thing as? So right now my decimal's right there after the 6. How many times do I need to move it over if I'm dividing by 100? You always move it over by the same number of zeros that we have in the bottom. So I'd move it over 1, 2 times, and so I'd have a decimal there. So what's my answer? 0.06. That's how we get the 0.06. Does that make sense to everybody? So although you might be able to look at it and just spit out an answer and think like, oh, it's 0.06, here's the strategy or the method to work backwards to break it down, to know for sure, because I could even take that up a notch and say 0.000049, and we want to figure that out. So if you're, a little iffy, unsure, and you want a strategy to break it down, here's how we would break it down to figure things out. So far, so good? Okay, so then a great way to end things off is with a sentence. The area of a square, well, do you all know how to find the area of a square? You did that last year? Good stuff. Is 144 meters squared. Yes, Mason? Oh, Mason, you just ruined the whole question for me. How could you do that? It is. It's saying what must be the length of each side. So what must be the length of each side? I don't know. Mason just told us what it is. So let's go through it anyways. Do you see that if we have a square, all of the sides would be the same length? You don't have to draw it out, but drawing it out is a good strategy to use to help think your way through things. So the area of a square, if I don't know the sides, do you see I could call them x? They would both be x. So what would be the formula if I just used what's written here? The area equals x times x, which is the same thing as x squared. Are we all good with that? And then in the question, it tells me the area of the square is this much. Where would I plug that into my equation? In for which variable? In for a. So 144 meters squared is equal to x squared. I don't know if you've ever learned this before, but this is algebra. Algebra is when you have numbers and variables, and we're trying to figure out what the variables are equal to. And algebra is all about opposites. You're going to hear me repeating that over and over again. So what is the opposite of squaring something? Because I don't want x squared, I want just x. How do I get just x? Square root it. So do you see that if I square root one side, like an equation is just like a scale. So if I square root one side, what do you think I have to do to the other side? Square root it, and then let's think our way through this. What is the square root of x squared? Yeah, they're complete opposites, so it's like we just crossed those off and I have x there. What is the square root of 144? 12, and if meter squared was the unit for area, what is it for just the one side? It's just meters. So x equals 12 meters. So we would say the length of each side is 12 meters. Good? Which Mason said about 5 minutes ago. Okay. So, here's what I would like you to do for 1.2. Section 1.2, you can work on numbers 1 to 5. You can do the odd letters, so we are all clear on what I mean by that now. I'm going to use that a lot. A, C, E, etc., etc. So you don't have to do all of them, you skip. And then 7, 8, 10, 12, and 13. So there's your work.